Alright, so let's now try to get the equation for velocity in simple harmonic motion. Right, so what do we know? We're taking this equation, not the cos equation, for the ease of doing the derivation. So we know the equation x is equals to a sine omega t. Great. This is the equation for displacement of any graph that starts off like this. If you plot the displacement x against time, this is going to be the displacement or the displacement curve. So this is the equation for this curve is a sine omega t, right? We know this from the previous derivation. Great. So if you know that, if you know the equation for displacement, now you can take the derivative and differentiate to get the equation for velocity. Great. So let's try and do that. Let's take the derivative on either side, and what are we going to get? We're going to get dx by dt, which is velocity, and if we differentiate this equation, we're going to get a times the sign is going to change. The sign is going to change into cos. If you don't know that, you need to revise your trigonometry and differentiation. So if you try to differentiate sine becomes cos. If you differentiate cos becomes minus sine. If you differentiate tan, it becomes sec square x. You don't need this, but I'm just saying it. So this is actually the few rules for differentiation. Sine becomes cos becomes minus sine, tan becomes sec square x. If d by dx. Great. So if you know that, the sign will become cos omega t. Now, this omega inside the parenthesis is going to come out because that is basically the constant in front of the variable t. So you're going to have omega outside. So let's say it was sine 2 omega t. You would bring out 2 omega t in front of the equation. As simple as that. So you have a new equation where a omega a cos omega t. This is the equation after differentiation, and this is going to be your equation for velocity. Great. So I hope you understand the differentiation process. If you don't, you need to do the trigonometry part, understand how differentiation works for trigonometric function, and then try and understand this. By the way, this derivation is not as important for you guys because you're going to be given the equation, and just knowing the equation is going to be good enough. You don't need to know the derivation, but if you know, your concept is going to be much clearer. So it's easier to understand why things are moving the way it is, or why the question is asking in a specific direction or in a specific way, how things are making sense in simple harmonic motion. That's why I'm showing the derivation. Anyways, so we have come across this equation now after taking the derivative. Now, a omega. What is a omega? If you remember the equation for velocity in circular motion, it was given by v is equals to r omega. You can relate that to over here. What is a? A is nothing but the maximum displacement. Maximum displacement. Omega is the angular frequency. So can you compare it to this equation? Here is r, here is a. So instead of r, we have the maximum displacement. So if you plug in the maximum r or maximum displacement, you get x naught omega or a omega. So if you have that, if you get v is equals to a omega, this is going to give you your v max, because the formula for velocity is r omega. Now what is the maximum value of r? Maximum value of r is amplitude in this case. And since omega doesn't change, the only variable was the radius or the displacement, and we have already plugged in the maximum displacement, which is amplitude, you're now going to get Vmax, which is A omega, or Vmax is given by x naught omega. Different books, different equation, different symbols. I don't understand why, but you gotta deal with it. So Vmax is given by x naught omega. So if you compare it over here, you do have A omega or x naught omega. So you can write V naught. Again, a new symbol. So V naught is nothing but Vmax, meaning maximum velocity. This is maximum velocity, max velocity. Why max velocity? I just said it because you're getting the maximum radius or maximum displacement in this case. So since the displacement is maximum, the velocity is also going to be maximum, because the displacement is already at its max and the angular frequency doesn't change. So the velocity doesn't get any bigger than this value. This V is equals to A omega. The velocity will never be bigger than A omega because you have taken the biggest value of R already. Great. So if you know that V naught, if you multiply A times omega or x naught times omega, you're getting V naught or maximum velocity. So I've just substituted V naught. I should write it like this. V naught is x naught omega, where this is amplitude. Great. So now you have the equation, the main equation. V is equals to V naught cos omega t. This is your equation to find out velocity at any given time. So if you draw the graph, if you draw this graph, you will get the maximum Vmax, and this is not V minimum, but since in the opposite direction there is a minus sign, so the Vmax is A omega over here. So A omega is the amplitude for the velocity curve. Great. So when we draw the velocity curve, you see that it's nothing but displaced by 90 degrees from the initial curve. If you look at the initial curve, which is a sine curve, we have basically moved it 90 degrees, and now we have the curve for velocity. Since you differentiate a trig function, the curve moves by 90 degrees leftwards. That's it. That's all that is happening when you differentiate a trig function. So this has now become a cos graph. This has become a cos graph. Great. So what is the amplitude of the cos graph? A omega. Why? Because that is in front of the cos function. This is the amplitude, and this is the curve for velocity. Great. So both of these are the same equations. I've just denoted as V naught or Vmax, whatever is easier for you guys to understand. Great. So you now know the equation for velocity. These are the equations. If you have maximum velocity given, you can plug in directly. If not given, and if you have amplitude and omega, you can put in amplitude and omega and you will get Vmax. So these are the two equations. Note it down. You will need this equation, both of these equations, or just this. You can derive this from this only. So once you have this equation, you can get this. And the other equation you need is the equation for displacement. Both of these are very important for doing sums in simple harmonic motion. Great. So now we have, after differentiation, the equation for velocity, where velocity is V naught cos omega t. V naught is basically maximum velocity. Good job. Now, the last and most important part. How to get acceleration in simple harmonic motion. You just have to differentiate the velocity curve once again to get the acceleration. So what is the velocity equation? It is V naught cos omega t. For ease of the derivation, we are taking V naught as A omega. We are taking V naught as A omega. as shown before. A omega is the same as V naught, so we're writing A omega. Great. So once we do that, we have the equation V is equals to A omega cos omega t. This is your equation for velocity. What do you do now? Take the derivative, dv by dt, and you take the derivative on this side. So as mentioned above, when I said this, cos becomes minus sine. Great. So cos will become minus sine. Where is it? Cos becomes minus sine. The minus is right in front. Great. So A omega stays as it is because it's a constant. Nothing is going to change. So A omega stays as it is. And what you do is convert cos into sine, bring a negative sign, and the omega inside is going to come out. The omega is going to come out, and since there are two omegas, you get omega square. So now you have the equation for acceleration. A is equals to minus A omega square sine omega t. But it's not done yet. The equation is A is equals to minus omega square x. So how do we turn it into that? Let's bring the omega square in front, and you have A sine omega t. Now does this ring a bell? You know the equation for displacement. If you remember the equation for displacement, it is basically A sine omega t. You can go above and check it yourself, where x is A sine omega t. So we can substitute x over here. A sine omega t, you plug in x over here, and you get minus omega square x. This is the main, most important simple harmonic motion equation. That equation, this very equation of acceleration, is the formula based on which the definition is written. This one. This equation is based on this equation. Sorry, this definition is based on this equation. Right, so now I've shown you how the entire thing is derived, how the equation is derived. This derivation is not in your syllabus. I mean, it's good to know, but you don't need to know the derivation. You don't need to understand how it comes by. But the important parts are knowing the equation itself, which is A is equals to minus omega square. Okay, I've written in summary. So the main equations to know is the equation for displacement, the equation for velocity, the equation for acceleration. Oh, right. So x can also be written as A cos omega t in case the graph starts from maximum position or starts from the amplitude. Great. So what are the max values in each of these cases? In case of displacement, what is the maximum displacement? A. Why? Because the maximum values for sine theta or sine omega t is always going to be between 1 and minus 1. So if you know that, for any sine function that is true. For any sine function, the maximum value is going to be 1 and the minimum value is going to be minus 1. So if you plug that in, you get, if sine omega t is 1, the maximum value comes out to be amplitude or A. So max value for displacement is A. You already know that from the graph. Next, we have velocity. For velocity, what is going to be the maximum velocity for cos as well? For cos theta or omega t, it's going to be between 1 and minus 1. So if cos omega t is 1, if this is 1, the max value for velocity comes out to be V naught, or it can be written as A omega as seen above. So max velocity is A omega amplitude times omega. Great. So what is the max acceleration? If you write the equation in terms of omega, you see that the amplitude comes out to be A omega square. Now, when is acceleration maximum? Sine omega t can be between 1 and minus 1. If sine omega t is minus 1, when sine omega t is minus 1, the minus and minus gets cancelled out, and you have a omega square. You have a omega square. So that is going to be your maximum acceleration when sine omega t is -1. So a omega square is your maximum acceleration. So if the question says that given amplitude is 3, a is 3, and angular frequency is 2 pi, what is the maximum acceleration possible? You can easily say 3 times 2 pi, 6 pi is the maximum acceleration possible. That's it. That is how this entire equation comes by. Alright, that's it for this video, and next up we'll look into other equations and also look into the derivation. Bye.